Hey everybody, the purpose of this video is to get you some solutions to this the skis homework. Why do skis work? Okay, so you read this first part, I hope. Hopefully this made sense. We talked about it a little bit in class yesterday about large area versus small area on a sharp knife. And this is the formula we want to play with right here. The idea of the average force applied by an object over an area, and that's this homework is kind of hitting on two things. The first that it's hitting on is the use of a formula for sure. The second is the units that are going to be applied to this, which is super fun. So let's just go through the math on this. Let's go through the math. Let's make it bigger so we can see it. Okay, so I said let's do my average force in PSI, pounds per square inch, without skis. I just measured the bottom of my shoes, and they're approximately 12 inches long by 3 inches wide. Let's just spell inches there. That's less confusing. 12 inches by 3 inches. Okay, if the area of the rectangle is given by length times width, what is the area of one of those shoes? Okay, so if it's length and width, it's going to be 12 inches times 3 inches. Okay, so numerically that's 36, and then unitly you've got inches times inches, which is going to be square inches. All right, so there's your first answer, 36 square inches of area on the bottom of my shoe. Now double that, and that's the area my body stands on each day. So if you got 36 on 1 foot, that means you're going to have 72 square inches on both feet. Okay, so now you've got square inches. Remembering that I weigh 180 pounds, that's what I told you up top. Now you're not going to use the boots and the boots and the skis for this one because I'm not using boots and skis. I'm just standing on my shoes, which you could assume don't weigh anything. Calculate my average force in PSI. Okay, so here we go. Here we go. We're going to take 180 pounds. Actually, let's do this as a fraction. Let's make it look pretty. There we go. All right, so we're going to take 180 pounds and we're going to divide it by 72 square inches. Okay, let's make that look like a fraction. There's my fraction right there. Okay, now what you want to do here is you want to knock this down so that it is, and I said pounds per square inch, not by 72 square inches. So what you're going to do, and we discussed this in class yesterday, is divide the 72 into the 180, and that takes care of the number. And if my math is correct, that should be, I think, 2.5, 2.5. And then you divide pounds per square inch, which is just pounds per square inch. And some of you actually, and I think Aubrey brought this up, if you want to, you can put a little other P in there. PSI is the common used unit. But I guess your point was a good one, in pounds per square inch. So if you want, you can put a little slash there, maybe, pounds per square inch. You won't see that like in the world if you go and do this kind of a thing in the world. But I mean, nonetheless, nothing wrong with doing that in this class to keep it straight. Okay, so that's, if you think about a square inch, an inch by an inch, a little tiny square, which is going to be roughly a quarter of like a Post-it note, or I'm looking around my desk now for something that looks like a square inch, maybe a thing of dental floss. That's probably even too big. Imagine something that weighs 2.5 pounds balancing right on that. So, you know, I think yesterday we mentioned a quart of water is 2 pounds. So a quart of water inside an Nalgene bottle would be about 2.5 pounds. So that balancing on a 1 square inch. Okay, so next thing we're going to do, that's my force that I generate standing around. Let's do it also with skis on. So I measured my skis. They're about 100 millimeters wide and 180 centimeters long, and we do that because they're from Europe, and we use European sizes, European units of measure. And let's convert them from millimeters and centimeters into inches. Okay, so they're 25.4 millimeters in an inch. We'll start with that. Let's see, fraction. Okay, so we have to go millimeters to inches. So in 1 inch, there are 25.4 millimeters. There's our conversion unit right there. And we're going to multiply that. This is an old Math 58 problem, right? We're going to multiply that by 100 millimeters. Okay? So we have to divide 100 millimeters, because a millimeters now, if you think about units, these are going to cancel. Boop, and you're left with inches. So then we just have to do the math. 100 times 1 is 100 divided by 25.4 is going to be about 4. Oops, that's the wrong button. I want to use insert symbol approximately 4 inches. So my skis are about 4 inches wide. Okay, so that's the width. And I think, I mean, we can use the exact same conversion measure if you want down here for the length. Long, I guess. Yeah, let's take the 4 because it won't be 4 because they are 180 centimeters long. So now what you're going to want to do, we're going to do a 2-part conversion here, although you don't have to. 1 inch is 25.4 millimeters. We also have to convert millimeters into centimeters. So what you have to do is you want to use another conversion that's going to get rid of millimeters and replace it with centimeters. Okay, so let's put that here. Toggle field codes. 10 millimeters is 1 centimeter. Okay, so now look what's going to happen. The millimeters is going to cancel. Boop, boop. But now you've got inches per centimeter, which you definitely don't want. You want to have inches, just inches. But we got to remember we haven't used the number of my skis yet, which is 180 centimeters. Okay, so now millimeters will cancel, centimeters will cancel, and you're left with just 10 times 180, which is 1,800 divided by about 25. Let me think about that. 1,800 divided by 25. 25 times 4 is 100. 4. I can't do the reciprocal of that. So we're just gonna run the math on this one. We're gonna figure out how many inches this thing is. So we're gonna do. Oh yes, I can. 25 times 4 is 100. So 4 times 18. That's about 72. It's gonna be about 6 feet long. Let's get more precision if we need it. 1,800. Divided by 25.4, 71 inches, about 71 inches long. That wasn't too bad. All right, 71 inches long. Whoops, let's put that over here. Okay, so the area down here, which is the area of my ski, is going to be 4 times 71, or 284. 71 inches times 4 inches, which is going to be about equal to 284 square inches. Okay, and then there are 2 of them. That's 1 ski. 1 ski. So, ... 2 skis would be double that, which would be 568, I guess. About 568. Still square inches. Still square inches because you're just adding 2 square inch things together. Double check the math on that. 8 plus 8 is 16. Yeah, carry the 1. So 586 square inches. All right, good. Average force on these puppy dogs, same exact idea. Take my weight, but remember, I said remember to add in the weight of my skis and boots. Let's go look at that. I forget what that is now. Boots. Skis are 14 pounds plus bindings, and boots are 5. So that's 19 plus 1. It's about 200 pounds. I'll call it 199 to be, I guess, precise. Although 200 pounds would be just fine. So that's 199 pounds divided by the 568 square inches. All right, I spelled all those words wrong. Square inches. Okay, make that into a fraction. Beautiful. And then the idea too is to divide the 568 into the 199. So let me think. If 199 were 200 and if 568 were 550, you'd have 4 over... Oh, the hell with this. Let's just get a decimal. 199 divided by 568. There we go. 0.35. I was guessing around a third, but I didn't want to mess around with my brain's kind of tired right now. All right, about 0.35 square inches. All right, pounds per square inch. Wrong unit. Pounds per square inch. There we go. Bold center. Okay, so check out the force difference. It's a third of a pound per, so it's ounces per square inch with skis on, and it's 2.5 pounds per square inch with skis off. Doing the math, if I divide 2.5 by 0.35, I end up with a multiple of 7. That's about 7 times less force. 1/7 of the force. So if you want to think about it, you might have a hard time comparing 2.5 pounds to 0.3 pounds, or 4 ounces or whatever that is, or 5 ounces. So imagine taking your weight and dividing it by 7. right? I mean, that makes a huge difference. That's, that's going from my weight of 180 pounds down to something like, 30 pounds or 25 pounds. I mean, it's a ridiculous drop in force. So the same thing. I mean, you don't sink into the snow like you do with just your shoes on because your weight is spread out over a larger area. Now, you do sink a little bit depending on the consistency of the snow. I've been on skis that have fallen well into snow. But on average, you're going to post hole a lot more regularly if you're using just shoes without skis. And I've seen poor skiers doing this when they try to hike out because they don't have the right kind of skis or skins or whatever, and they have to walk out. And it's miserable, absolutely miserable experience. But anyway, that's why skis work, and hope that helped. We'll see you in class.